Hello everybody, today we are going to be talking about scientific notation. Hopefully this is a topic that you've already been introduced to in your physics classes or your math classes, but we are going to do a short review of it today just to make sure that you're up to speed for this chemistry class. So, first things first, why do we use scientific notation / what is it? Well, we use scientific notation to make really big or really small numbers more manageable. For example, 3 billion. This is a huge number. If I had to write this out every time I wanted to write the number 3 billion, I would get a little bit annoyed. But I can use scientific notation and I can condense all of those zeros into just this format right here. So there's 3 billion, right? The 3, and then there's 9 zeros. That's what that 9 there says. So I've got 3 billion. I can also do it for really small numbers. So for example, I have all of these 0, 0, zeros right here in front of the 3. Now we know that counting zeros is a little bit challenging, but if we condense this number, it becomes a little bit easier to manage as well. So we have 3. This time it's times 10 to the negative 9th. Now we're going to talk a little bit more about what these exponents mean, but for now, you should hopefully from math be aware of the difference between a negative exponent and a positive exponent. So let's break that down a little bit. There are multiple parts to scientific notation. Now the first part is the coefficient. So let me change my color here. The coefficient is the first number, so that would be the 3 in both of these cases. 3 is the coefficient. This is always a single digit number 1 through 9. You can have a decimal, so I could say 3.1 or 3.0, but I couldn't say 30 or 31. You can only ever have one digit before the decimal place in scientific notation. Then the second part is the exponent. The exponent tells you how big or small the number is. So like I said, from math, we should know the difference between positive exponents and negative exponents. Positive exponents tell us that the number is greater than 1. 3 billion is clearly larger than 1. Those negative exponents mean that we have a very small number. So something less than 1. That's what a negative exponent means. Now let's use that information to talk about how do we get into scientific notation. So here's some examples that we'll work through. Let's say I have this number, 78,000, and I want to put it into scientific notation. Well, I know that I can only have, with my coefficient, one number before the decimal place. So my number is going to start off with 7. Right? I want to make sure that I include the rest of those digits, so it's 7.8000, okay? And then I'm going to have times 10 to some number of exponents. Now, what we didn't really talk about was how did I figure out that number of exponents? It's all about where the decimal started and where the decimal ended. So in this number 78,000, we can pretend that there's a decimal right here. If I have to put the decimal right after the 7, how many times do I need to move my decimal place? 1, 2, 3, 4 times. So in scientific notation, the answer is 7.8 times 10 to the 4th. Oh, look, and that matches. These zeros here aren't really required for us to write. You can just write 7.8 times 10 to the 4th. So because the number is greater than 1, I knew I was going to have a positive exponent, and then I had to move my decimal 1, 2, 3, 4 times. So that's how I ended up with the exponent of positive 4. Let's do another one. So again, I can only put one number before the decimal place. So 2.687. The question is, what becomes of the exponent? The number is greater than 1, so I know I'm going to end up with a positive exponent. The question is, positive what? Well, the exponent, or the decimal is here, so I can move it 1, 2, 3 times to get it between the 2 and the 6. So the answer is 2.687 times 10 to the 3rd. What about for a number that's smaller than 1? We learned on the last slide, for numbers that are smaller than 1, we're going to end up with a negative exponent. The question is, of course, what number will that be? Well, our decimal is over here. We know that the decimal needs to end up between the 5 and the 3 because we have to have a number between 1 and 9 as our coefficient. It has to start somewhere between 1 and 9, and we can only have one digit in front of the decimal point. So in order to get my decimal from there to there, I'm going to need to move it 1, 2, 3, 4 times. So my answer is going to be 5.3 times 10 to the negative 4th. And that negative is there because my number is smaller than 1. My original number is smaller than 1. It's very important that you understand that I am not changing the value of this number. I am simply rearranging the way that we write it so that I don't have to deal with all of the zeros. Right? It's like a condensed form, but I didn't change the number itself. Let's do another. Again, this is a number that is smaller than 1, so I'm going to have a negative exponent. The question is, what number exponent? I have to move my decimal 2 times to get it after that first digit. So my answer is going to be 1.2654 times 10 to the negative 2. Negative because it's smaller than 1, and 2 because that's how many times I moved my decimal point. Now that's how we go from a standard notation into scientific notation. What if I gave you a number that was in scientific notation? Could we go the other direction? Let's find out. This is how I recommend doing it. We know that this exponent here tells us if the number is going to be greater than or less than 1. Since this is a positive exponent, I know that the number is going to be greater than 1. So I need to add zeros at the end of this coefficient. Right? I could add, it could be 0.0052, it could be 5200, right? Just as an example. If I wanted the zeros in front of the number, my exponent would have been negative. If the zeros are going to come after the coefficient, then that's why my exponent is positive. So if I want to put 5.2 times 10 to the 5th into standard notation, I need to move my decimal 5 times to the right, because that's how I'm going to make a number that's greater than 0. So 1, 2, 3, 4, 5. So now my decimal's at the end, and I'm just going to fill in these empty humps here with zeros. And look at that. I've got 520,000 of whatever it is. That's how you get from a number in scientific notation back into standard notation. Let's do one that has a negative exponent. So here I have 6.542, so I'm just going to rewrite the coefficient. The exponent is negative, so I need zeros before the 6 here. So I'm going to have to move my decimal to the left, and I'm going to move it to the left twice. 1, 2. So now my decimal is here. I'm going to fill this in with 1 0, and my answer is 0.06542. So you can rewatch this slide as many times as you need to, but we are now going to go on to give you a try. So go ahead and pause the video, and on a separate sheet of paper or on wherever you're taking notes, try to put these numbers either into scientific notation or take them out of scientific notation, putting them back into standard notation. So pause the video, and then we'll get back together in just a second and go through these answers. All right. So with the first number here, we have a number that is greater than 1. I'm going to end up with a positive exponent. In order to figure out that number, I move my decimal 1, 2, 3 times. So my answer is 9.103 times 10 to the positive third. In the second one, I have a number that is smaller than 1, so I'm going to end up with a negative exponent. And it's going to be 1, 2, 3, 4, 5, 6. It's going to be a negative 6, so my answer is going to be 4.38 times 10 to the negative 6th. Now, in 3 and 4, we are taking scientific notation and putting it into standard notation. So positive exponent means I'm going to have zeros after my coefficient. So I take that 2.71. I'm going to move the decimal to the right 4 times. 1, 2, 3, 4. Fill that in with zeros. So my answer is 27,100. Last one, I have a negative exponent, so those zeros have to come before the coefficient. So that 1.0079, I'm going to take that decimal place, move it 4 times to the left. 1, 2, 3, 4, and then fill in those zeros. So here are those final answers for you, written out all nice and pretty. I hope that you got them all correct. If you are still struggling a little bit with this, you do have a scientific notation practice worksheet that I'm going to have you go through. So work on that worksheet. The answer key for that will be posted as well. And then you can always stop by my office hours if you need a little bit more help, like congruently. So if I can help you work through some practice problems on the office hours, I would love to do that. Good luck!